Okay, mic check 1, 2. Good morning, everyone. And today we're going to cover the Chapter 10, Module 10, Network Management. There's several interesting things in this one, so the bits and pieces that we're going to cover in this. Okay. Too much echo, I got to turn this down. Okay. Change up in the lab. There was originally going to be 2 labs here, but when I was running through these labs in Packet Tracer, they don't work in Packet Tracer. The first lab, 10.6.11, using TerraTerm to manage router configuration files. Well, there's it just doesn't work like stated in the lab. We had real TerraTerm and a real machine that would work okay on that. I'm going to do some lab demo stuff. This is similar to that in Packet Tracer. 10.6.12. Using TFT flash and USB. Again, we don't have a real device to plug a USB device into. I'll give a demonstration of that. You can do some stuff in Packet Tracer. You actually can do password recovery in Packet Tracer on the router. You can't do it on the switch. So I'll show that today. So the lab that you guys will be assigned is the lab 10.8.2. I reposted that on the student lab printouts page. And that's going to be some of the subjects in today's presentation is Cisco Discovery Protocol, which is Cisco proprietary, link layer discovery protocol, which is open source that everybody has, and the network time protocol. Okay, let's see. So I guess I should try to bring up the first slide here and see if we can get going. Let's see, unshare this. Share now. Oh, I can't share now. Click on it and share it. Okay, here we go. Should be showing up. Okay, so network management, and here's what we're going to talk about in this particular chapter. Cisco Discovery Protocol is a proprietary protocol, which is very useful for doing labs and very useful in the real world when you want to map out what devices you're plugged into. It's proprietary to Cisco. The dangerous thing is it's on by default. So it's useful to have on within the corporation because we need it for the phones. We want to at least turn it off on that serial port or that Ethernet port that goes to our service provider so the bad guys don't use that to figure out what we're doing. Link layer discovery protocol is similar to Cisco Discovery Protocol, except it's not proprietary to Cisco. It's an open source technology that gives us much the same type of information. We'll look then at network time protocol. The big picture with network time protocol is you want all your servers and routers and switches to be on the same page as exactly what time it is. So when the bad guy breaks into the system and then he goes from the employee that was stupid enough to click on the phishing link and then he sort of metastasizes his way into the rest of the network, we can follow him through with the system logs on all the servers and routers and switches as he goes through. If they're not in sync with each other on the time, it's hard for us to figure out where did he go to here, where did he go to there in order. We'll look at the simple network management protocol, which has no bearing whatsoever to his dyslexic neighbor simple mail transfer protocol. They both start and end with the same letter. And that's a network management protocol that's used so that you can run a network management workstation and see what's going on with your devices. So try to be more proactive than reactive. Syslog is a feature that will allow us to save our log messages to an inexpensive file server. It doesn't have to be a hardware server. It can be any old desktop. We'll look at that. And then we'll look at router and switch file management. I think I have found out the problem of we're going to try to see if we can do this little 5-6 minute video today. I think you guys will be able to see it and view it. I got a help desk Blackboard thing that tells me how that's supposed to work now. And then we'll look at iOS image management. So Cisco Discovery Protocol. Now, it's a layer 2 protocol. This means that, for example, if you're going to do a lab. So in this picture, he's got a switch and a router connected together. I would do some very simple configuration on the router and the switch. I would give the router a host name like R1. And I will give the switch a host name like S1. And then I would plug them together in a real lab or in Packet Tracer, just plug them together with the virtual solid Ethernet twisted pair cable. And all I have to do is do a no shutdown on that Ethernet port on the router. I don't have to do any shutdowns whatsoever on the switch, because switch ports are come up by default without any commands as soon as you plug a wire into them. And then when I go and I show CDP neighbor on either device, I should see the other device. It may take a minute, but it'll come up. It's on by default on all devices. So this is great within our enterprise. I didn't have to assign any IP addresses to anything for this to work. All I had to do was do a no shutdown, which brings up layer 1 and layer 2, and the port is active and the light turns green, and we can see all these other devices. Lots of information, including a lot of dangerous information that you don't want malicious intruders from the outside world to be able to see, such as what the exact IP address of the device is, what version of the iOS he is running. This is useful information to someone that would want to get into your system, because if you're running an older iOS, some people aren't real careful. Some organizations aren't that careful about keeping their operating systems up to date. And if I find you have an older operating system and there's an exploit, there's a vulnerability for that, I could use this information that I get from show Cisco Discovery Protocol detail. It would tell me all that stuff, and I could maybe use that to break in. So on by default, we can type show CDP, and we see that it's on. Now you have a choice here. You can turn it off globally for the entire device. You can say no CDP run, and it'll be turned off for the whole device, all the interfaces. Most people today, however, really need CDP running, at least on the internal interfaces within the organization that are going, for example, to all the telephones. So most enterprises today, they run one wire to a cube, or they run one wire to an employee office, and they're going to share the Cisco phone traffic and the employee's desktop PC data traffic over that one wire. We looked at that in the previous chapter about how you can trunk the cable to the office, and the computer's data is untagged traffic, and the voice traffic is tagged traffic, and the voice switch and the telephone, the little 3-port switch and the Cisco telephone will separate out the raw data, untagged traffic, and send it to the PC, and it'll use the tagged traffic for the voice VLAN to make the telephone work. These voice telephones need Cisco Discovery Protocol. Well, some of them can run on link layer Discovery Protocol as well. They need that in order to discover from the switch what extension should they be, how should they operate in the system. So we need to have it running pretty much within the organization to all the Ethernet ports that are within the organization, so that telephones will work properly. But we want to be able to turn it off for that interface port that goes out to our internet service provider. So we can do the no CDP enable on that particular. So let's say it was a G00 interface on the router that went to AT&T or Verizon, whoever my service provider was that was giving me connection to the internet. I could say no CDP enable on that one individual interface and still leave CDP running on all the other ports so that my telephones would work properly. So CDP run by default is on. No CDP run turns it off globally for the whole device. And then we're probably going to leave it running for almost every port in our enterprise, and we'll just turn it off for those ports that go to untrusted areas that we don't want to give away the farm. So we can use the command show CDP interface, and it'll show us which ones are enabled, what the status of each one is. So in this case, he's typed the command show CDP neighbor, and the prompt is R1, you're at the router, and he's typed the command show CDP neighbor, and the router is showing us. Let me see if does the mouse work here? Is there mouse action? I guess there's no mouse action here. This shows us the orange letters at the bottom show us that our neighbor device that was detected by R1 was the switch, and his host name was S1. And the very useful information here is on the second column. The port on the router, gigabit Ethernet 0/0/1, and under the heading local interface. And then the one at the very end of the listing, the last right-hand bottom side orange says fast Ethernet 0.5.
This allows us to verify that our wire that's plugged into G001 on this router R1 is plugged into the fast Ethernet port 05 on the switch. So this is very useful information. When you're doing a laboratory, what you can do is just simply give each device, some labs have 3 routers, some labs have 3 switches, some labs have 3 routers and 3 switches. Just go into each device and give them a host name, R1, R2, R3, S1, S2, S3. Do a no shutdown on all the ports that connect the devices together. And you don't have to go ahead and do any IP addresses or passwords or anything of that nature. And then just check with show CDP neighbor. For example, if it's a router lab with 3 routers in the triangle configuration where R2 is in the middle and R1 is on the left and R3 is on the right, just as a quick check, go to R2 and type show CDP neighbor, and you should see R1 is connected to your S00 port and R3 is connected to your S001 port. These are typical configurations for our labs. And you can check and make sure that all connections are okay. Before you go and spend a lot of time configuring some device and you think you're configuring R1, you're configuring R2, and for some strange reason your lab doesn't work because the configuration is not right. Now here's the dangerous one to the outsiders. Show CDP neighbor just show me that simple line. It showed me that my G gigabit port was connected to this fast Ethernet port, and its host name was S1. Show Cisco Discovery Protocol neighbor detail shows a whole lot of information about this other device. It tells us what its IP address is. Now this is very useful if you're an authorized individual. If you want to figure out what IP address should I telnet to, the thing about Cisco Discovery Protocol is it only shows you a directly connected neighbor. So R2, the man in the middle, would see R1 on the left and R3 on the right. But if you did show Cisco Discovery Protocol neighbors from R3, he would only see R2. Only one hop away. Only the directly connected neighbor is shown. But if I was trying to, say, go into, this has happened to me before. I went into a company and everything was working, but they had no documentation. And they were Cisco devices. So fortunately, they knew their password. I was able to log into the first device and then show CDP neighbor, see the second device. Then I found out the second device's IP address and I telnetted to it. And then asked me to show me his neighbors. And I could branch out through the organization and learn all the routers and switches in the organization that were connected in that fashion. The bad side of this is from the standpoint of a malicious intruder or a threat actor who's trying to get in and map out what you got. He can see what version of the iOS you're running. And if it's an older iOS that has an easy way to get in, like a vulnerability, he can use that to get in there. So that's why you want to disable this going to the outside world so they can come in and see this stuff. Okay, link layer discovery protocol is the equivalent of Cisco Discovery Protocol, except that, stand by, just checking attendance. The difference is link layer discovery protocol is open source. It's not proprietary to Cisco. So if you've ever had the experience of you open up the network control panel on your Windows computer and it shows you that you're connected to the internet and it shows you that you're connected to your home router, he's using a link layer discovery protocol to figure that out. It works very similarly to Cisco Discovery Protocol. When we do this lab, first of all, you're going to do CDP and you'll show your neighbors, and then the lab is going to instruct you to turn off the CDP and turn on link layer discovery protocol, and you're going to see similar thing. It'll show you this port number of the router is connected to this port number of the switch. But it works with not just Cisco devices, but other devices as well that support link layer discovery protocol. Now, Cisco Discovery Protocol was on by default. Every port activated. Link layer discovery protocol is off by default. You have to turn it on. And then once you turn it on, though, it's going to work in a very similar fashion to the Cisco Discovery Protocol. Again, it's a layer, the data link layer protocol. All you have to do is configure the port to be in the no shutdown mode where it's operational. And even if you haven't assigned IP addresses to it yet, this is going to work. Now he says that it may be enabled by default on some devices. On the devices we have in the lab, our 1941 series routers and our 2960 series switches is off by default. It may be on some other devices by default, depending on the manufacturer. So on a Cisco device, where we type CDP run and CDP no run, on the link layer discovery protocol, we'll type LLDP run, and that will turn it on for the whole device. And then we can go to the individual interfaces if we want to turn them on or turn them off. Yes, we can have them running on the interfaces we need on our interior corporate network structure, and we can maybe turn it off for that interface that goes to our outside world internet connection. Now, some enterprises use link layer discovery protocol for their voice over IP telephones. So it's essential that it's either all voice over IP telephones are going to use either CDP or LLDP, so that when they turn on, they can figure out, what extension are they supposed to forward to, and what's their phone number supposed to be, and all that stuff. They need to get that information from the switch. So we can type show link layer discovery protocol, and it'll show some information about this. Now notice the similarity of this report shows CDP neighbors that we saw earlier to show LLDP neighbors that we're seeing now. So here we're seeing that the same sort of thing is being shown here. Switch 1, in this case, we've got a switch, and he's connected to a router, and he's connected to another switch, and he's showing us that his neighbor R1 is connected through the S1's fast Ethernet 05 port, is connected to the gigabit 0/0/1 port of the router, and the two switches are connected together from port 1 to port 1, very typical for our labs, and you can see how they're connected together, and he'll show you a little bit of information about that. Now, we can also see some more advanced information. So show link layer discovery protocol neighbor detail shows me a little bit of extra information about that particular device. So again, this is information that you would not want a malicious intruder or an outsider that has no business learning this to try to use, so that he could, he's going to perform his reconnaissance and try to figure out what IP addresses you have. And then when he finds out interesting devices, he's going to do an nmap port scan on them to try to find servers with port 80, so he can try to find stuff to break into. So very similar to Cisco discovery protocol, but open standard, and it can work with many different devices. Okay, now the big picture here with the network time protocol is we want to sync the time process on all our devices so that their log files are in sync with each other. Now, it's not that super important that we be absolutely synchronized to God's time, to the National Bureau of Standards Stratum 0 thing to the exact microsecond. But what it is important is that all our devices are synced to each other very accurately to within a fraction of a second, so that we can track when someone breaks into the system from one device and then they jump to another device. We'll be able to line up the log files with each other and check this out. Now, like desktop computers, Cisco devices have a battery backup in them that keeps track of the date and the time, but it can not be exactly in sync with the others. So when we use this network time protocol, what we're going to do is just arbitrarily define one device, maybe our best, most powerful router, as a master clock, and then we're going to have all the other devices synced to that. So too difficult to go into each individual device and manually set the date and the time. So we're going to configure the network time protocol on our network with one device or maybe two devices, and then use those to synchronize everything else. So you could synchronize it to a publicly available server on the internet. The United States National Bureau of Standards provides a standard for that if you want to use theirs. On Windows computers, you can go into the set date and time thing, and you have a choice of using time.windows or some other setting to synchronize it. So what we're going to do is choose some device within our corporate network structure here, and we're going to define it to be the master clock. So Stratum 0, that's the absolute WWV, National Bureau of Standards, accurate to 1/1,000,000th of a millisecond type clock. We could synchronize to that if we wanted to. Or we could arbitrarily set our own within our own enterprise. So when you do this packet tracer lab, I think he's going to have you say Stratum 3 will be master, the NTP master, and then you'll synchronize your other devices up to it. So you can go from stratum 0 through 15, and anything that's above that level 16, that's like, you know, in RIP, there's 15 hops and you're dead. 16 hops, 16 stratums, you're not synchronized at all. So stratum 0 devices, these are the ones that the government maintains. They're very accurate. Stratum 1 devices are devices that are directly connected to these devices. They would be the primary time standard for our network. Then stratum 2 and lower, they're connected back to stratum 1 devices as a reference. So we're going to use a stratum 2 or stratum 3 device in our network in the packet tracer lab as a synchronization reference standard for this. So you can have 2 if you want to sort of back each other up. Okay, before we do the network time protocol on a device, we're going to type show clock. And if we type show clock detail, it tells you that the time source is the user configuration. The user typed in the date and the time by hand, just checking his wristwatch or something. So we want to set it to a time server instead. So in this particular device, R1 is not our master for the network. It's a secondary device that wants to lock to the master. The master device is this device. In that middle of the printout, it says NTP server 209.165.200.225. That's the server that has a higher stratum, or a lower number stratum level, more authoritative level for this enterprise. And it's been configured to be the NTP master. We'll see that code in a bit. So after he says on this R1, he wants it to not rely on the battery backup clock. He would rather rely upon the master time server for the entire enterprise so that all the log files are in step with each other. So he types the command NTP server and the IP address of that server. And then it can take him 1 or 2 minutes for this to take place. Then when he goes back and types show clock detail, instead of saying the time source is the user configuration, which means the battery backup clock and that chassis, it'll say the time source is network time protocol. And it'll be absolutely locked into the correct time. So we can verify this command. We can verify this NTP configuration. We can type show NTP associations. And in this print, he's showing us that the orange 209.165.200.225 is the reference clock that he's synchronized to. And when he types the command show NTP status, it shows us that the clock is synchronized and that it has a certain amount of precision. So in this case, the clock on S1 has been configured. He wants to synchronize to R1. So he went to the secondary device and he typed NTP server 192.168.1.1 was the address of not this S1 switch, but some other device, perhaps a router that's been configured to be the network time protocol reference standard. And then after a couple of minutes, it can take a while, after a couple of minutes, when you type show NTP associations and show NTP status, you'll see that it's locked into it. And you have to have IP connectivity for this to work. Now, when we did show Cisco Discovery Protocol and we did show LLDP neighbors, no IP addresses were necessary, but this uses IP connectivity. So after you bring your interfaces up with no shutdown and connect them together, and if you can ping back and forth between these devices with a proper consistent IP address scheme, then the NTP is going to work for you. Okay, Simple Network Management Protocol is a protocol that's been around for quite a long time. There's some older versions that you shouldn't use and some newer versions that are much more secure. So this was a way that instead of having to log into each router or switch or server and check the log files and check the status of things, we're going to use a Simple Network Management Protocol so that the devices can communicate with a management agent, a management station, typically a high-end PC that's located in a network control center for a company, so that he can keep an eye on all these devices and he'll expect periodic reports from them on their status, maybe every 30 minutes. And there's also a feature that if something goes horribly wrong, the network management workstation will know before the next 30 minutes has elapsed. So the network manager
is a device that runs on a management workstation. The simple network management protocol agents, these are our managed nodes, a router, a switch, maybe a server. It's kind of unusual, even though the code is there to do this on users' client PCs. Some people do it on printers so they can keep track of when printers go down. And each managed device, like a router or a switch, has a little database in it called the Management Information Base, which is a list of all of the things he's saving up to send back to the management workstation when the next 30-minute or whatever the pre-configured interval is. This is user datagram protocol. No TCP, sync, ACK, positive acknowledgement, and retransmission. He just sends it out UDP, and ports 161 and 162 are used for this to exchange information back and forth. So in this diagram on the left-hand side, we've got a simple network management protocol management workstation. It's running something like, Hewlett-Packard OpenView is a popular one in industry. That's very expensive, but you can get open source programs that do the same sort of a thing. So in this case, the simple network management workstation is wanting to check the status of an interface port on the device. He can send out a GET message and get, is this interface port up and up? How many interface resets have occurred on it? The same sort of thing you would see if you type show interfaces. He can get that information and have it go sent back. If it's not a read-only environment, it's a read-write environment, the simple network management protocol can actually change the parameters of a router or a switch. Now, the earlier versions of simple network management protocol were not that secure. You couldn't even encrypt passwords. There was generally only two passwords. There was a read-only password called public. What was the default password? Public. The default password for read-write was called private. And the problem was simple network management protocol was on by default on lots of devices, including Cisco routers and switches with these default passwords, and people didn't realize they were on. And so someone could come in and knowing the default passwords of public and private were in effect, and they didn't know the privileged exec mode password, they could still come in and change the configuration of a device and mess up that device. So the recommendation these days is to use the highest level of simple network management protocol, version 3, and where you can put very secure passwords in there. So you can get the information back from the device. You can set the configuration of a device if you have the proper password. Now the devices are programmed to send, like maybe every 30 minutes, each device will send a summary of its status back to the management workstation. But what if something goes terribly wrong? There's a trap procedure that says, for example, the G00 interface should never normally be down. If it should happen to go down, then it's 15 minutes to the next update. Don't wait to send this update. Send a trap message to the network management console so he knows immediately that something's going wrong. So in this operation, we have these agents that on the managed devices like routers and switches. They collect the same sort of information you would see if you type show interfaces or other show commands. And then the management workstation would use this agent code to do a GET request, show me the status of the interfaces, or do a PUT request, change the configuration of a device using GET and SET. So GET requests are the things that retrieve values for the status of an interface. How many collisions have there been? Is the interface up and up properly? How many bytes or packets of information has it had in the last 30 minutes? And then the set requests are ones that actually change a value in that managed device. So an agent would respond. That agent is the code that's running, on this case, this router R1 on the right, the blue router. So if the network administrator at the network management workstation on the left says get a variable, that would be like actually logging into the router or telnetting into the router and doing show commands, see what's going on with that particular device. Except that
She has the convenience of everything on one screen from lots of devices. She doesn't have to log into 100 routers and switches at one time. She can get the big picture of the network all in one thing. So network managers that are responsible for keeping the network operating can use these network management softwares, and they'll see all green, they'll know everything's cool. If they see some reds and yellows on it, they know something's going wrong. And so they can try to be more proactive with fixing the problem than with waiting until someone calls the help desk and reports problems. Also, that the network manager can send out a set a variable. She can send a set message out and see what's going on with the particular device or change the parameters if she needs to. Okay, the trap is let's say that the router was programmed to send a summary every 30 minutes. And then sometime between the pre-programmed 30-minute intervals, something goes wrong. In this case, the gigabit port has gone down on the router. So instead of waiting for the update, the code in the router, the simple network management code in the router says, oh, this is really important. Someone has set a threshold here, and the interface going down exceeds this threshold, and I must send a trap message back to the simple network management protocol workstation. So it'll send a message back, and she can see that, or the screen, some part of the screen will turn red and catch her attention, and she can know that something's going wrong. Okay, simple network management protocol. Oh, I mentioned that it was on by default. And when I first started teaching Networking Academy in 2000, it was on by default. And the threat actors, the malicious intruders, the black hats were using this to get into systems and not only see, but change information. They were hosing systems. It was on by default, and a lot of people didn't understand it. So Cisco made some changes in the early 2000s and said, well, it's off by default now. If you want to turn it on, make sure you understand it first, and then turn it on and set the parameters properly. There was a similar vulnerability in the iOS of early Cisco devices in the early 2000s that the web browser was on by default, IP HTTP server command. And you could come in with the default web server, which is running, and you probably didn't realize it. And you could see things and maybe even change parameters. So they turned that off by default as well. We had a similar issue with Windows, Microsoft Windows Server 2000. All the versions of NT Server up to 2000, they by default installed the web server, Internet Information Services. And even if you didn't ask for it, you probably didn't want it to be on. You probably didn't even realize it was on. You were just wanted a file and print server to take effect. And so the hackers, the wares guys would use your free FTP and web server on your machine to store their wares and tell their friends where to download it from. So starting with Windows Server 2003, Microsoft changed their philosophy and said that no, the web server is not installed by default anymore. You actually have to click and go through the installation procedure deliberately if you want it to be operating. So simple network management protocol version 1, very high security risks, this default passwords. They fixed some of the problems in version 2. They used better authentication and had more detailed messages in it. But everyone today really should be using version 3. So it has, the problem with the 2 earlier versions is that all the information that the agents were sending back to the management workstations was totally unencrypted in the clear. You know, like we previously talked about with FTP and Telnet, everything's in the clear. So version 3 added the ability to encrypt the data. We can hash our usernames using MD5. We can encrypt our data using something that keeps, anybody can get a free copy of Wireshark and see this stuff. And at least that way they're not able to see the stuff that's going on in the rest of the system. So you would use version 3 today, the most latest version, if you wanted to use it. If you don't understand it, don't turn it on. Okay, these fixed passwords that were present in version 1 and version 2, these community strings, this is the famous public and private passwords in plain text. It was literally the word public and literally the word private, set by default. If you had an early Cisco router switch and it was on, the SNMP was running by default, you didn't realize it. These preset passwords that all the hackers knew would allow them to be able to get in and mess up your system. So the read-only string, this is the public password. The default was public, lowercase public. You could see stuff. You couldn't change it. Well, at least they can't hold your router configuration, but they can see what you're doing and see IP addresses, and that might give them more information that they could use to try to figure out where the servers are. The read-write community string, that's literally the password private, lowercase private was the default. And that means you could actually send out put and set messages, not just get messages. So you could literally change the configuration of a router and mess it up or ruin it in a company, and then they got to come in and fix it. The management information base in the router or the switch has this sort of hierarchical arrangement of data, and they're called object IDs. So there's a sort of a tree that we go through here that the RFCs have set up, and it kind of looks like this. Here's Cisco's. So they go through this branch of Cisco's been assigned the ISO. Remember the ISO dreaded, feared, and hated 7-layer reference model? Yeah, they're behind all this stuff. So Cisco has been assigned this ISO layer down through org, Department of Defense, the ARPANET model, Internet, private enterprises, and then Cisco. And then that branches off into interfaces and management things. So the actual code, which is an arcane code to type, 1.3.6.1.4.1.9, you're supposed to type all that stuff? Gosh, do I have to do that? Well, no, you don't. You can just use a management workstation to do it, and you won't have to type in all the little individual numbers. So if you had to type it from the command line, he's typing SNMP get version 2C, the community password and the IP address of the device that he's polling, and then the all that 1.3.6 stuff, and then it returns a string of integer 11, which is the obtained value according to he was trying to look at what's the CPU utilization of this particular device. So that text mode stuff's very hard to type in. You would use a network graphical user interface network management workstation to do this. So here's an example of one from Cisco, Object Navigator. It's a GUI, and you can click on it, and you don't have to type in these long variable names. So you can use this, or you can use a more sophisticated network management product like HP, Hewlett-Packard OpenView, and keep an eye on everything that's present in your particular enterprise. Okay, now let's talk about Syslog. And you notice when you type in commands on a router or a switch that sometimes a line of, like say you do no shutdown, and then you get ready to type something else, and right as you're starting to type the next line, it chops your line in half and you put something on the screen about that interface you just typed no shutdown on. Yeah, it's coming up now. Layer 1's coming up, layer 2's coming up. You get a couple of lines on the screen, and it appears on your console. And then after you type enough lines, it scrolls off the top of the screen, and it's kind of gone forever. You can maybe scroll back on the screen or show history and maybe see it, or maybe it's gone because it has a limited amount of buffer space. So what I would rather do is, let's talk about a malicious hacker again. He gets into maybe a user's PC, and then he goes into the switch S1, and then he propagates from there to router R1, and we use a network time protocol now so that our logs are synced with each other. But it scrolled off the top of the device, and no one was plugged into the console port at that moment, so we're unable to see the error messages that he generated. But it's retained in a log if we take the trouble to set up a system server, a Syslog server. Now, you see the word server there, and you think expensive $20,000 server. This is a very simple program that you don't have to have a dedicated server hardware. You can run it on an old workstation and just set that workstation up as a Syslog server, buy a cheap, gigantic, high-capacity hard disk drive and put it in there. And you can store all your log files for all your devices for long periods of time before you fill up that hard drive. And then if you need to go back and correlate the logs with each other, you'll be able to use the date timestamp, which is set properly, and you'll be able to correlate what happened between the switch and the router as activities progress through them. So he talks about the Syslog server being able to gather information for monitoring purposes. We can select, do we want the complete warts and all, every single error message and pop-up message that appeared on that screen, or do we just want more crucial information? There's 8 different levels that you can choose from. And then we can say, where do we want these captured syslog messages to go to? In this case of this diagram, he's going to send it to an inexpensive syslog server. Okay, so normally the syslog protocol would send system messages, debug output to a local process. It would go to across the network to a server. You don't have to go to the actual device. Normally they also go to an internal buffer. By default, you see messages like when you type no shutdown, you see a message appear on the screen telling you that the device has changed from the administratively shut down to the operational status. But there's a limited internal buffer. When you go into the command line interpreter, like to the console port, or you telnet or secure shell into it, there's only a limited buffer. So we can specify what goes to various destinations. If I wanted to go to that hard drive on the syslog server, I could say, well, you know, do I want everything or do I just want limited types of information? We're going to see that severity level here in just a second. So the logging buffer is the RAM memory inside the router or the switch. You have to come in through the console line to see that, or you have to come in through a terminal line like a telnet line. We can send it to a syslog server, and that eliminates the problem with the limited buffer memory that's present in the router or the switch, and it'll be stored on that huge disk drive we put in the syslog server. Now, the question is, how much information do we want to be stored on that hard drive? Well, hard drives are so cheap now, I kind of like to see everything, but you can filter this. So level 0, emergency level, that's only the most severe messages. Oh, the system's crashing now. All the way up to the debugging level, everything, what I call warts and all, you get to see everything. So the lower the number, the less you'll have, the less data to be stored on the syslog server's hard drive. The higher the number, if you put it at level 7, everything that occurs will be logged to that server. So you can choose the level that you need to go back and forth. Okay, so here are some things we normally see when we do stuff on the Cisco devices like routers and switches. We'll see messages like the IP address has been set, or if you do the OSPF protocol, you'll see a neighbor relationship has been established with the other OSPF router. We'll see messages from the iOS operating system. If we're configured IP security, we'll see that. Interfaces up and down as a result of no shutdown or shutdown commands or wires coming loose being plugged into a device. We commonly see these messages pop up on the screen. And I call these Cisco annoyances because usually when they pop up on the screen, you were typing something else and it sort of chopped your message in half. So by default, we get this type of format. So a Ethernet channel, Ether channel link has changed state to up. So it puts a message up on the screen. This is severity level 3. It says link 3, up, down. And the interface, the port channel, when we did Ether channel, we bonded 4 physical Ethernet ports together, and they became a port channel, so we could get around the STP, not making any of them work except one. Change state to up. So it's changed up, and this appears on the screen briefly, but if you configure the syslog server, it will also be sent to the syslog server. So long as you're looking at severity levels 3, at least as high as 3, you'll see these. Now, if you're configuring to a syslog server, first of all, you should have enabled network time protocol so that all the devices' log files are in step and in sync with each other. But second of all, sometimes by default this is done, but in the middle of this screen, he's gone to the configuration mode and he said service timestamps log date time, and then when messages are sent to the syslog server, it's going to include at the end of the log, each log line, it's going to include the accurate date and time that when this event actually occurred. So when we go back through our log files, we can line up the date and time on this switch with this router and try to track, say, for example, some event has progressed through the system, like a hacker trying to go through and go from one device to another device. Okay, router and switch file maintenance. So let's go to a router and type the command show file systems. And we got a bunch of stuff here. What are we going to use all these? That's one of the ones we're mainly interested in. In the architecture of a router and a switch, we have a flash memory instead of a spinning hard disk drive, because flash memories don't have any moving parts and they should be more reliable. So in this case, the flash drive is the boot device. The asterisk indicates that this device is the one that's going to boot up. And we see the size and how much free memory it has in it. Then we also have our NVRAM, where we store our startup configuration file. That'll be stored in that location. And he hasn't plugged any USB. Well, in this case, it looks like a USB device has been plugged in, and this shows the capacity of the USB drive and how much space is available on it. The flash memory is the default file system. So instead of typing the command show space flash, we can just type dir, and we'll get the same exact thing as if we type show flash, and we'll see all the files present in our file system. Now on the routers that we use, the 1941 routers, you don't have these dozen lines here. You just have one line that has the iOS in it. I'm going to do a demonstration of iOS on Packet Tracer, and we'll be able to see that shortly. To be able to look at the contents of the NVRAM, you use a Linux type command. Now he calls it present working directory, and when I started learning Unix many years ago, that was called print working directory. In other words, PWD will tell you what current directory you're in. Print the working directory onto the screen. So it tells us we're in the NVRAM directory because he typed CD NVRAM, change directory to the NVRAM folder, and then he can list the files that's present in here. So in our older routers, our 1941 routers, the only thing that's normally present in the NVRAM is the startup configuration file. On the switches, they alias it to another name, but that's what it looks like. Okay, so on a switch, when we type show file systems, we see on the switch normally we just have the flash memory that has the switch iOS in it, and that gets stored in compressed file form on the switch. And then when you turn on the switch, it's expanded into RAM memory, and it runs it from RAM because RAM's 10,000 times faster than flash memory. Then we also see that NVRAM has showed that's where the startup configuration is stored for this particular device. So same command. Now, this was a lab that I originally intended you guys to do in the real lab, because in the real lab we have TerraTerm on the PC, so we can do this stuff. But we can't do this. There's no TerraTerm in Packet Tracer. It has a sort of a simulated screen. But the idea here is that when you're in TerraTerm, if you want to back up, say, the running configuration, you can type the command show run. But before you do that, go into TerraTerm and turn on the log or capture ASCII text to screen, and it'll save it to like a notepad file, a text file on the screen. So that you can turn on this feature, and then you can type show run, hit the spacebar 3 or 4 times to see the whole running configuration of the device, and then you can stop the capture, and you're going to have to clean it up. What you're going to have to do is when you go and look at that file, it's going to have a bunch of more messages where each time you hit the spacebar, the screen stopped, and you have to press the spacebar to see more. You're going to have to go in and clean all those out. And there's going to be some garbage stuff at the beginning and at the end. But the idea is you can clean up this file in Notepad and then go back to the beginning of Notepad and add the word enable and config T. And then when you want to take a configuration and put it back to an erased device, let's say you do a lab one day, you save your configuration, you come back the next time, oh, the Cisco one guy's erased it. Well, you can bring up the device and then just paste back in the file. And since it has enable and config T at the beginning, it'll place the router in the privilege exec mode, and then it'll place the router into the global configuration mode, and all those files can be pasted back into place, and it'll become the running configuration for the device. So that's kind of a shortcut to get it running again. Okay, now let's talk about using TFTP. TFTP is a stripped down version of file transfer protocol. It's called Trivial File Transfer Protocol. And TFTP does the same sort of thing that FTP does, a couple of minor differences. It doesn't use TCP. It uses user datagram protocol. So it has its own built-in reliability and sequencing and so forth. It doesn't use any names and passwords. and it's stuck with a single directory on the server. Very, very useful for network devices like routers and switches to back up the running configuration, or to save the iOS, or to move a new iOS. I'm going to give a demonstration of that in Packet Tracer in a little bit. It's very oftentimes used by the cable companies that you give home internet service from. If they want to update your operating system in the company supplied cable modem, they'll TFTP it to the cable modem. If they want to upgrade the configuration file in your cable modem because you paid for a new level of service and get faster bandwidth, they'll simply TFTP a new configuration file to your device. And then you don't have to do anything yourself. So we oftentimes use these in the commercial world with managed devices like Cisco devices. So we can save the configuration, restore configuration, save an iOS to back up, and have restore maybe a new version of the iOS if we need to do this. So this command is kind of similar to the DOS command. In the black screen at the bottom, he said copy running config TFTP. What he wants to do is back up the existing running configuration to the TFTP server. So he types that command, and then the guided configuration dialog asks you, what's the IP address of the TFTP server? And he types in the 192.168.10.254. And then the next guided configuration question is, well, what's the file name that you want to save this at on the TFTP server, the cheap desktop you've set up as a TFTP server? By default, R1-config. So this user has typed in R1 and typed in a date to differentiate it from the last month's backup. And then it writes a configuration file. It's very short. It just takes a few seconds to write, and it says it to that particular device. And I'll show you this on the Packet Tracer. It does a pretty good simulation. So here's a Cisco 4321 router, the next generation of routers. Even our routers, our 1841 and 1941 routers we have in the lab, have USB ports. So as an alternative to having to connect to a TFTP server and download a new iOS or back up the iOS, we can simply copy it, much like you would on a desktop PC. You copy a file from the hard drive to a USB drive when you're back into dump. We can plug in a USB device into these routers, and we can save it back and forth. Now, our switches don't have this feature. Our switches don't have any USB ports, but the routers do. So I would say, in this case, I would put a USB device into the router port, the USB port on the router, and check with show file systems to make sure it was mounted, and then type the command copy run USB flash, and it would copy it over. In this case, it's already been present on that, and he backed it up, and he wants to override it. Then we can use our USB to back up and restore a configuration file. So he saved, when he did the directory listing of the USB flash at the top of the black screen printout, he sees that that R1-config file has been saved. And then he can print it to the screen and make sure it's proper. Okay, now let's talk about password recovery. You might find this hard to believe, but sometimes people leave the company and no one knows what the passwords are anymore. You might find this even hard to believe. Sometimes under the circumstances which someone has left the company, they're mad and they change all the passwords and then leave, so that it's going to make it even harder for whoever they hired to replace them to do something. So there are password recovery procedures for all network devices like routers and switches, or for our Microsoft servers. They generally require physical up-close access to the device. If I need to recover and reset the password on a switch or a router, I need to be able to have my hands on it to do it. You cannot telnet into a router and do password recovery. There's no such way. Cisco publishes the password recovery procedures for all their devices on their public web pages. Oh goodness, anybody could do that. Well, no, you have to be able to get into the closet, get into the network area where all the devices are and do that. Okay, so there's two kinds of security. There's physical security and there's technical security. Physical security is the device is locked and only the appropriate people have card keys to get in that room. Technical security is I've got the password so I can log into the server and change somebody's password.
So to do the password recovery on a router, you have to be able to get into the Raman mode. Now I'm going to try to illustrate this in Packet Tracer in just a little bit. But the step, think about your Windows desktop PC and you install a new graphics driver for your new gaming super VGA video thing on it, and when it boots up, you get a blank screen. Oh, there was some problem with that video graphics driver that you installed. How do you recover from that? Well, let's see. On Windows, you have to press F5 or F8 or hold down the Shift key or something like that when the desktop PC is booting up, and you can go into the safe mode, and then you can install the proper device driver. Go into the safe mode at 640 by 480 video resolution, and you can correct the problem with the graphics driver because at least you can see the screen now. So this is the same sort of thing. We want to interrupt the normal boot up process of the router or the switch so that we can, because when Windows boots up, he boots up the Windows operating system and then he loads the Windows registry with all your parameters and passwords and stuff. If you boot into the safe mode, you can bypass that and maybe reset the password on your Windows machine if you've forgotten the password. So on a Cisco device, on a router, what we want to do is interrupt the normal boot up procedure. We want to issue the break command over Terraterm to be able to do this. In the Packet Tracer, you type Control-C, and it'll interrupt the process where the iOS is booting up. You see the hash marks appear on the screen, and normally if you didn't stop them, they would load up the iOS, and then the iOS would load up the configuration, startup configuration file with the password you didn't know, and you'd be locked out. So instead of pressing F5 or F8 and going hit the safe mode on the desktop PC, we're going to go into the Terraterm program and issue the break character, and then we're going to boot up into the, we're going to change the configuration register to a value that says, go ahead and boot up the iOS, but pretend the startup configuration file doesn't exist. It's still there, just ignore it. We're going to change this hexadecimal value of the config register from 2102 to 2142. And now once we boot it up to the router's prompt, it'll say default name router. You can go into the privileged exec mode with no password required. So you can promote yourself to the privileged exec mode and then copy the startup configuration back to the running configuration with the password you don't know, but you're already at the privileged exec mode. You don't need the password. And then just do enable secret class and change it back to the password you know. Resave that as a new startup configuration and you change the password. I don't care what the old password was. I just want to reset the password to something I know, and then I'll be able to redo it. Now there's a gotcha in here they forgot to put. Any interfaces that you apply the no shutdown command to, when you do the password recovery technique, you're going to have to type a no shutdown on them again. Otherwise, none of your interfaces will be up and running. So here's the screen print. He's booted up a router, and you have about 30 seconds to do this. While the router is booting up and you see that hash marks appear on the screen, you've got a very short amount of time to apply the break sequence. And it depends on, if you're using Hyperterminal, it's control break. If you're using Terraterm, there's a menu command that will send the break character. And when you do this, the boot will stop, and you'll get this ROM monitor prompt. And at that point, you'll be able to change the configuration of the device. So at the ROM monitor prompt, if you type show version on a normal router, it says 2102 is the normal configuration register setup. That means boot up normally. I'm going to change that configuration to 2142. And that is going to say, when I reboot the router the next time, that's going to say, go ahead and boot up the iOS. And after the iOS boots up, normally it would go and load the startup configuration. But what 2142 says is, ignore the startup configuration. Act like it's a totally erased router. You're going to get the prompt on the screen that says, do you want to go into the guided configuration dialog, which you would normally get if it was a totally erased router. It's acting like a totally erased router. Even though the startup configuration is still there in NVRAM, you can still show start, you can still see it. So he types the command config 0x, which is the code for hexadecimal value, 2142, and then type the command reset, and the router will boot up again, and when it finally finishes booting up,
it will act like an erase router, and you can just type enable and go straight to the privileged exec mode. It has the default hostname of router. Now, at this point, here's a danger. Your muscle memory on your fingers wants to type copy run start. You don't want to type that. If you mistakenly now type copy run start, you will take the default erased running configuration and wipe out that startup configuration that precious startup configuration file that has the total configuration that's not backed up anywhere else, and you just erased it. So be very careful when you do password recovery. You're going to type copy start run. You want to do what the router does normally every time he boots up. He takes the NVRAM startup configuration and he punches it into RAM. So as soon as you do that, notice that the prompt changed to R1. You're already at the privileged exec mode. Now you can go to the global configuration mode with config T, and you can reset the router, enable secret class or whatever password you want to use in your enterprise. So in this example, he sets the password. Of course, we use Cisco in class in the Network Academy. So if someone forgets to erase the router, you can get it and reset it yourself. In the real world, do not use Cisco and do not use class. Use good passwords. Okay, now we need to do a couple things. He forgot step 4B, which is go to all, do a show IP interface brief, look for all the interfaces that have IP addresses assigned to them, do no shutdown on them. And then the second step is, step 5 is, when we went into the ROM monitor prompt and we changed that configuration register to 2142, we got to change it back. Otherwise, it'll never boot up after we fix the problem with the new password. It won't boot back into the previous configuration. It'll still act like a brand new router. So the command config register 0x2102 at the global configuration mode reverses the config register 0x2102 I did at the ROM monitor command. Okay, so now I've reset the password. I've done the config register. I went all the interfaces and then no shutdown that had to be, that were being used. Now do a copy run start. Save the configuration with the new password you now know, and then you can reboot the router. You don't have to reboot the router, but the next time it goes up and down, it'll be okay. It's running now. You can do this in less than 5 minutes in a production environment during the day and get a machine running up again if you didn't know what the password was. Okay, ain't gonna do this lab. Ain't gonna do this lab. Let's look at iOS image management. Okay, the video is supposed to work now. I'm gonna go to the video screen now, and let's see if we can hear this. So I'm gonna guinea pig this on you guys. You should be able to see this. So I'm gonna stop this demonstration here. Go back to share files, share application, share a Chrome tab. It's this one. Oops, oops, oops. Stop sharing. I need to click something first. I didn't do it. Okay, share application screen, share Chrome tab, share. I forgot to click the button that says share audio. And if this works properly, you should be able to hear this.
To upgrade the iOS image on a Cisco router, you'll need the following items: a computer or PC with a terminal emulation program like PuTTY,
Okay, I had to turn my monitor speaker down because otherwise my microphone from the first PC is feeding back to the second PC. Okay, so what I want to show now, let me see if I can share files. And what I want to do now is share the application packet tracer. Be shared, be shared. Let me see if I can zoom it for size here. Okay, that's about as big as we can get it. So here's what I want to illustrate is this. First of all, I want to bring a router onto the screen. Let me see. I want to click on a router and bring a 1941 router like we have on the screen. And I'm going to bring in a switch in here because I just want to make sure the interface goes up and up. And I'm going to make a connection between the G00 port and the first port on the switch. Now I'm going to go into the router and let's see, I'm going to give them a host name, go to enable config T, host name R1, and let's see, line console 0, password Cisco, and then enable secret class. Normally do. And I'm going to go to the interface G0/0 and give them an IP address. How about 1.1.1.1? Just make it quick and easy. Shutdown, because I want to illustrate this shutdown problem. Okay, let's do copy run start. So we have a password saved, and we're going to pretend that we don't know this password. We want to get into the device. Okay, so normally then if I type log off, I want to go to the privilege exec mode, I'd have to know the password class to be able to get to that. But let's say I didn't know what it was and I was supposed to be able to get into it, okay. So I'm going to type the reload command, and on the hyperterminal, I type Control-C. On a hyperterminal, you would type Control-Break. On the TerraTerm, you would type, there's a menu command for the show. And so what we're going to do now is do the password recovery on this. I want to go and type the config command, 0x2142, 2142. So I've changed the configuration mode now so that when it boots up, it will boot up into it will boot up and pretend there's no startup configuration file present. So I'll type command reset. Boot up. I'm not going to do Control-C this time. I want it to boot up, and it should act like a router that's been erased. See, he's asking me the question. So I say no. I'm at what appears to be an erased router. I can type the enable command, and I go to the privilege exec mode, even though I didn't know that it was enable secret class. Okay, so if I do show IP interface brief at this point, he didn't say my IP address, did he? Okay. Maybe a bug with packet tracer. Okay, so what I want to do is, I don't want to type copy run start. I want to do the reverse. I want to type copy start run. And look, my file name's R1 now. Okay, he took the previous configuration and he put it back in. But if I do show IP interface brief now, look at that gigabit 00. The IP address is there, but he's administratively shut down. Okay, let's fix that. Let's go config T, interface G0/0, no shutdown. Okay, that fixed that. Now let's fix the password. Go to config T, enable, secret. I'll use Cisco this time. And now I've reset it to password that I know. Now there's another problem I need to fix before I can do this. Show version. The configuration register is still set to 2142. I need to change that back with config-register 0x2102. Now when the router boots up again, I fixed everything now. Now I can do my copy run start. Everything's saved. It's a password I know. all the interfaces are running, and that's going to be fixed properly. Okay, so that's what we sort of went on the slides. Now, let's do some iOS management here, and let's actually use this to solve a problem that Packet Tracer has. I'm going to go into Packet Tracer, and I'm going to start a new topology. And I'm going to go into the devices, and I'm going to choose the network switch, the 2960 switch. And I'm going to bring in, instead of a workstation, the PC workstation, I'm going to bring in a server. Because this is a pretty cool server in the Packet Tracer that has has a web server, it has a Syslog server, it has a TFTP server. That's the one I'm interested in right now. Okay, let's do some base connection with IP addresses and ping back and forth between them, and then I'll show you how to fix a problem with this default switch that's present in Packet Tracer. Okay, so I'm going to click on regular Ethernet connection, and I'll connect it to the first port of the switch, which is kind of off your screen. I connected to port number 1. So in 50 seconds, that orange light will change to green, and we'll be able to ping back and forth between the devices. So while we're waiting for that to take place, I'm going to go to the server and click on the server, and let's bring the configuration screen over here. And I want to go into the desktop and go to the network control panel. And I'm going to make this server 1.1.1.11, and we'll just take the default subnet mask. That should work just fine. There's no router in here, so we don't need a default gateway. Now, oh look, the switch port turned green because it takes 30 to 50 seconds for spanning tree protocol to take place. And I'm going to go into the switch. And let's go to the privileged exec mode, and let's go to the global configuration mode, and let's give them a host name of S1. And then let's go to interface VLAN 1 and give them an IP address. How about 1.1.1.2? We'll say 1.1.1.1 for the router that's not here. I'm doing no shutdown. So if I type show IP interface brief, looks like my VLAN's on the up and up, and can I possibly ping that server now, which was 1.1.1.11? And it worked. Okay, the first dot was due to ARP latency of ARP lining up your layer 2 data link layer and MAC address with your layer 3 IP address, logical IP address. Okay, now we need to go over to the server now, and I need to copy and paste that file. Oh, wait a minute, here's the problem. Here's the problem with the switch that we're going to overcome. So type show version, and we can see that the version that's in this switch is 12.2. That's an older iOS. So I was able to apply that IP version 4 address to the switch, to the VLAN. But let's see, can I possibly apply an IP version 6 address? I want to do an IP version 6 network. So IP version 6, IP version 6 address. And he goes, what? What? No, I don't understand this IP version 6 stuff. I can't configure it. Oh no. So you can't apply IP version 6 address to this poor little guy. But what we're going to do is we're going to upgrade the iOS to a later version so that we can't do that. Okay. And we also want to be able to change the shows switch database manager. He can only set the default template, and we want to change it to the IPv6, dual IPv6 and IPv4, and this iOS version doesn't have that. We can't do that. So we're going to fix that. We're going to put a new iOS in it. Okay, now I can go back to the server. And what I want to do is go to the services tab, and what we're interested in is the TFTP server. So the service is on. Okay, I should be able to TFTP to it. Stuck with that one directory. But what I want to do is look in these files here. I want to look at these files for the 2960 switch. I have version 12.2. But look, there's a newer version of the iOS for our switch, iOS version 15.0. Okay, I'm going to copy that into the clipboard. So I'll have to spell it out correctly and type it exactly correctly. I should be copied to my clipboard now. So what I'm going to do is go back to the switch prompt. And let's see, was I able to ping that device? It was 1.1.1.11. I'm okay. So I want to copy from the TFTP server to my flash memory, that newer version of the iOS. So I'm going to press enter, and I should be prompted. What's the IP address of that TFTP server? 1.1.1.11. What's the source file name? Oh, I should be able to paste that into there. Oh, look, it pasted. Oh, good. I wanted to retain that same file name in the iOS flash memory, and it copied it. And how can we verify this? Type dir. Oh, look, now I have the old one and the new one. So I want to make the new one be in charge, because the default of a device when it boots up is it boots the first line of the directory. Okay, so I'm going to go to the configuration mode, configure terminal. And I'm going to issue the command boot system, and then he wants me to put in that command. I'm just going to paste it. Now I should be able to do a copy run start, and do a reload. And it looks like it's loading the new iOS. We'll check with show version after it boots up. And then we'll see if we can apply an IP version 6 address. Okay, show version, which should work even from the privilege exec mode. Okay, and it's loaded the 15.0 version. Okay, let's go to the privilege exec mode. Let's go to the configuration mode, and let's go to interface VLAN 1 and IPv6 address. About the link local address, FE80::2 link local. Oh dear, what's going on here? Show IPv6 interface VLAN 1. Okay, show IP interface brief. Up and up. So let's try this again. Configure terminal. Interface VLAN 1. IPv6. Acting dumb. It worked yesterday for the other class, I swear. It's not working properly. Address 2020::2/64. It's some bug in packet tracer. So I was able to show you copying the iOS back and forth. This iOS is supposed to, I know what the problem is. Oh dear, oh me. It's not a bug, it's me. Okay, let's do a show SDM preferences, and we need to change the SDM preferences, and then we'll be able to work. I forgot to do this. Okay, so what we're going to do is what you have to do in the lab if you want to apply an IP version 6 address to the switches. Our switches in the labs are the latest version. They'll support it. But the problem is the default switch database manager. So I'm going to go to the configuration mode and say SDM preferences. And our choices now are dual IP version 6. Yeah, that's what I want. And I want that to be the default. So I'll do a copy, run, start. And I'll do a reload. And at least in packet tracer, this reloading is quicker than on the real devices. On the real switches and real routers, it takes about 3 minutes to boot up. But in packet tracer, they just boot up in a few seconds. Okay, now let's go to the privilege exec mode, and let's go to the global configuration mode. And let's go to the interface VLAN 1, and let's see if we can apply, now you're cooking with gas. 2020::2/64, how about that address? And just for fun, let's apply a link local address as well. IPv6 address FE80::2 link local. Okay, the port's already should be still running, should be up and up. Now here's an actual bug in Packet Tracer. If I do show run, here's the IP address for VLAN 1. IP version 4 address is not, the IP version 6 address is not, doesn't appear here. Now it's actually in there. We can prove it. Show IPv6 interface VLAN 1. And there's our address. There's our 2020::2. It's there. There's our FE80::2. It's there. It's working properly. So now we can actually apply this. Now our parent academy, our Cisco Parent Academy Education Service Center has put in a request to the Cisco Help Desk to have this add the feature added to Packet Tracer so that when you upgrade the iOS of the switch, it remains upgraded, because right now you have to do this little procedure every time. Oh, it takes 5 minutes. Copy the new iOS, change the security switch database manager over, and you'll get it to work properly. Okay, so let me stop this. Stop sharing this. And just a reminder here that we're going to share the greeting screen. Okay, so I've covered everything in this a lot of stuff to cover today. The original labs I assigned here, 10.6.11 and 10.6.12, don't do those. They don't work good in Packet Tracer. Instead, I want you to do this integrated lab 10.8.2, which I posted in the student lab printout section. And you'll do, this all works perfectly well in Packet Tracer. You'll be able to configure Cisco Discovery Protocol and see your neighbor device. You'll be able to configure a link layer discovery protocol and see your neighboring devices. You'll be able to configure network time protocol. You'll configure the router as the master. You'll configure the switch as the to point back to the master to get it. It takes about 2 minutes for switch 1 and switch 2 to learn their addresses. So what you can do is type show. You can say show clock detail, and just keep pressing it over and over again, and it says it'll change to the NTP in a couple of minutes, and the time will be synced up in that. Okay, so I think I've covered pretty much everything now. Let me check attendance to see if anybody showed up here. Okay, so please perform this lab, and Tuesday we'll go on to some more modules, and I'm going to mute my microphone now and stop recording and say thanks, guys, for showing up, and I'll look forward to seeing all you guys next time.